Hey everyone, it's Chris. Welcome back to another tutorial in our Tetris tutorial series. And in this tutorial, I've decided to go ahead and go over how to level up, such as increasing our difficulty when we're playing our game, to make things, a little more difficult for the player, because, it wouldn't be any fun if we just stuck around in the same level the whole time. So let's talk about what we can do to add something that'll make it more difficult to play the game. Plus, before we do that, we're going to want to go through and optimize a couple of things. And by that, I mean here, I'm going to show you. If we click play here, with the way the game currently is, when the pieces start dropping, you can press the down arrow to make them drop faster. You can hold down the down arrow to make them drop faster. Left and right, same thing, right? So here's what happens. If we press the left button and just keep holding it down, the piece just stops moving altogether. Well, we don't want that because that allows the player, a clearly way too much time to think about where to put this piece. So we let go and a piece starts dropping again. Same thing if we go to the right. So we'll want to go ahead and optimize our code to fix this problem. And the way we're going to do that is in the Tetramino class, okay, we have this check user input method right here. What we need to do is we need to break this up. For one. Two, we have this button down wait timer. We're going to separate this button down wait timer into a button down wait timer horizontal and vertical. We're going to split this out into its own if statement, okay, so that it isn't part of our horizontal movements. And then we're going to separate out all of these else if statements into their own if statements. And then we're going to create 4 new methods that are going to hold our code for movement and rotation. Okay, so let's go ahead and start with that. Let's go ahead and create those 4 methods. Okay, so we do void move left, move right, move down, and rotate. Alright, so let's do our summaries here. Keep our code organized. Moves to the left. Moves to the right. Oops. Moves down. Rotates. Alright. So now that we've got those, we can go ahead and our if statements. So we'll see right arrow, so this is for moving right. So we'll go ahead and take this all the way down to the else if statement, right? And we'll cut. So right click and cut. And that was the right movement, so we're going to paste that into here for move right. Okay, let's collapse that in. And then for our left movement, which is the left arrow here, we're going to select this, cut, and paste this into here. Collapse that. We'll do the down movement, just right here. Select all the way to this closing curly bracket. Or no, that was too much. All the way to fall. Okay. So cut here. Paste that into the down. Alright. And we'll do the rotate. Select all this. Cut. And paste that in here. Collapse. Alright. So now all we need to do is go in here and say move right, move left, rotate, and Okay, there we go. That's so much cleaner. The other thing we're going to do is we're going to separate these. We're going to take out the else's, because what we're doing when we're saying else if is we're saying that if one of these is true, or if one of these is not true, then go on to the next one. So if one is true, then we can never do the other. So what I mean by that is we want to be able to rotate our piece while we're moving it left and right, right? So if we're holding down the left button, we want to be able to rotate our piece also while we're doing that, because when the pieces go very fast, we need to do multiple things at once. And if we have if else, so if this right arrow key is pressed, then that's going to be true, and the else is never going to run as long as this right arrow key is pressed. So rotate we would never even get to. So we need to make sure that rotate is in its own. And the other thing is the down. If the down is in an else statement, then down isn't going to happen if we're holding down left or right, or also if we're pressing left or right. So we can get the piece to actually move slower down while we're pressing left and right, and that's not fair. That makes the game too easy. So these are all in their own if statements, okay? So now what we're going to do is we're going to take this right here, what I said before, button down wait timer. We're going to create another variable. Actually, we're going to rename this one to button down wait timer horizontal. Then we're going to create another one called button down wait timer vertical. Okay, so that is here, button down wait timer. So we'll rename this to horizontal. And then we'll create another vertical. Set that to 0. Alright, so now all these button down wait timers are red because that variable doesn't exist anymore. So what we'll need to do is first let's take this, right, for down arrow, we'll cut that out, get rid of this or statement here, do another if statement, paste that into here, close that if statement, and we've got that. We're going to and put all the vertical stuff in here. Okay, so moved immediate vertical goes in here, and vertical timer goes in here, and button down wait timer vertical equals 0, and then this will be horizontal. Okay, now those are taken care of. Now our check user input, that's all it is. So that's just much easier to manage. Now we have to go through and fix our actual movements for the button down wait timer. So this would be horizontal since we're going left. So is this one. And for going right, will also be horizontal. And finally, for move down, we are doing vertical. Oops. Alright, that's that. Okay, so let's have a look and see if our game is still playable without any errors, and let's see if we fixed our problem. Alright, so here's our tetramino falling. So now we can go left, right, just like we were supposed before. We can also rotate the piece as we're holding the button down. And if we hold the button down to the left, the piece continues to fall just like it should. Okay? You'll just have to trust me that I'm holding the left button down. Anyways, so that is that. Okay, so now that we've got some of the optimization stuff out of the way, what we should do is we should actually go ahead and start working on what the video is about, right? We want to add some difficulty to our game, okay? So the best way to do this, and really this is how all the, I think all the Tetris games work this way, is you clear lines, and for every 10 lines you clear, you go up a level. And for every level you go up, your speed at the fall rate increases so that the pieces actually fall faster. So how are we going to implement this? Well, first, you'll notice that we've got a fall speed, which is a public variable on our tetramino class, which means that every single tetramino has its own fall rate. and that's not what we actually need here. We need a single fall speed that we can assign and continuously update, and that the tetraminos will pull from. Okay. So what we're going to do is we're going to change this to a private variable. Okay. And we're going to not make it equal anything right now. Now, what we need to do is we need to create a public fall speed variable, okay? And it's going to be a float. So we're going to put it right here, public float fall speed. And we're going to set that equal to 1.0f. And that's how we're going to start with fall speed. So now that we have our fall speed set in the game class, we can go into the tetramino class and say, hey, I need to know how fast I should be falling, right? So how do I figure that out? Well, we know that in the game class we're setting the fall speed, so it would make sense that if we're setting it there, then we should be able to retrieve it from there. So the way we do this is because we have an empty game object. Let me show you. We called GameScript, remember? We created this empty, called it GameScript, and we assigned an audio source, and we actually also added the GameScript, the actual script component onto this empty game object. Well, in Unity, there's a class, or there's a method on the game object class that allows us to find game objects by name, and then once we have found the game object, we can actually access the components of that game object, being the game script. Okay, so we can go something like this. We say fall speed equals game object dot find. Okay, and you'll see how this method actually asks for a name as a string, so we need to put it in quotes. Okay, and for the name, it's called GameScript. Okay, and we can verify that by just looking here at our hierarchy. We'll see GameScript. Okay, that is the actual name of the game object. So then once we have our game object, we can say, okay, well, we want to get a component of this game object. And which component do we want? We want the game script. Okay, that's the class. That's the component that's in our game script game object. And from this class, we want to get a property. And the property is fall speed. And the reason that we can access that is because we assigned it as a public variable. Okay. So now, our tetraminos will behave just as before because they have a fall speed value, right? So let's go ahead and make sure that that works. We're going to jump back into our game real quick, press play, and our tetraminos are still falling just like they should at a speed of 1. So now what happens when we increase the fall speed? Well, nothing happens, because what we're doing is in our tetramino, we're only setting the fall speed here once at the time that the tetramino is created. And that's only because I'm showing you guys for a quick way to do this. The other way to do this would be to just throw this into the update loop, because then it would update every frame. In my opinion, that would be a bad thing, because calling this GameObject.find is actually pretty expensive in terms of CPU usage and things like that. I mean, it's not going to make a difference in the grand scheme of things, because I'm pretty sure there's not a computer out there owned by anyone that, I'm not going to make assumptions here, but computers have come a long way, and frankly, if this is going to cause problems running 1 frame per second, then we've got some other concerns that we need to deal with. But anyways, if you want this to continuously update, just put it in the update loop. Otherwise, keep it in the start, and it gets the speed that the last speed was before the last line was cleared. So we'll get to that in a second too, right? Because we need to actually update. So in order to update this fall speed, we're going to jump back over to our game class. We need to create 2 more methods. We're going to call them update level and update speed. Okay. And here, let's do this. Let's go ahead and make sure we call these at every frame. Update level. And update speed. So we want to update level. We can't update level yet because we don't even have a variable for level. So what I suggest we do next is we create ourselves a variable. We'll call this, we'll make it a public, and it'll be an integer, and we'll call this current level. Okay, and we'll start that out at 0. All right, so we'll also need to keep track of how many lines have been cleared throughout the entire game. So we'll need another, and this can be a private integer, and we'll call this one non-lines cleared. And that one starts at 0 as well. Alright, so before we get into the current level thing, we need to make sure that we increment our number of lines that have cleared. Okay, the number of lines that have cleared, that's easy enough because we've already made these methods here. Right? Cleared 1 line, 2 lines, 3 lines, 4 lines. So we know how many lines have been cleared. And from here, all we got to do is num lines cleared. Here it's only incremented by 1, so we can do plus plus. And here it's 2, so we do plus equals 2. And here, oops, do 3, so plus equals 3. And here we'll do 4, oops, plus equals 4. Alright, so that increments our number of lines. And what did we say earlier? We said we want to increment our level based on the number of lines, right? So if we've cleared 10 lines, we want to go from level 0 to level 1. If we want to go to level 2, we would have had to clear 20 lines. So how would that work? The best way to make this work is to just say current level equals, okay? And we're going to be dividing the num lines cleared by 10. So the way this works is 0, right? Let's say that we've got 0 lines cleared, divided by 10. That's 0. 1 divided by 10, 2 divided by 10, 3 divided by 10, 4 divided by 10, all the way to 9 divided by 10 is going to give us 0. Not a decimal number, not 0.1, not 0.2, because we're working with integers and not with floats. So our current level will remain at 0 until we actually hit 10. Once we divide 10 by 10, then our current level is going to switch to 1, because we've cleared 10 lines, so now we're at level 1. All right. So same thing applies. Once we get to 11, we do 11 divided by 10. We still get 1. Really, it's 1 point something. Because we're actually, you know, if we actually did the division with a float, then we would have a decimal, right? But we don't because we're using integers, and that's what we want to do. We want to have, we don't want to have a float as a level value. We just want to have you know, a 1, level 2, level 3, level 4, level 5, and that's what this is going to do. All right, update speed. Okay, so we want to update our speed, and the best way to do that is because if our fall speed is 1, we're dropping 1 unit every 1 second. If our fall speed is 0.5, we're dropping 1 unit every half a second. If our fall speed is at 0.1, then we're dropping every unit at 0.1 seconds, okay? So we have to actually decrease our fall speed and not increase like you would, you know, immediately assume. So we actually have to make that a lower value. All right. And the best way to do that is we basically just take the current level, multiply it by 0.1, and subtract that from our fall speed. So we say fall speed equals, all right, so we take our maximum value, right, which is 1.0, right, and we subtract We're going to cast this as a float, current level. We're going to times that by 0.1f. Okay. So we're subtracting by the current level times 0.1f. Well, if we're at 0, then if we're at 0, then 0 times 0.1f is going to equal 0, and our fall speed will stay at 1. Once our current level changes to 1, then we've got a current level 1 times 0.1, which gives us 0.1. Then we subtract 0.1 from 1.0, which gives us 0.9. Then our fall speed actually equals 0.9, and our pieces are going to fall faster. Okay? So that does that. And, okay, so that pretty much covers it, I think. Let's go ahead and give our game a try. And just for now, just so that we know what's going on, we're going to do some logging. Because otherwise, how are we going to know what level we're on? Because we haven't added that menu thing yet. So we're going to, though. We're going to do the GUI stuff. So this is just for testing. So we're going to see here, current level. And we'll just grab the current level variable here. And then we'll do current fall speed. Fall speed. Okay. All right. Let's play. All right. So now you'll notice that when you're looking at the console output here, we've got current level 0, fall speed 1. All right. So let's go ahead and see if we can clear some lines. Okay. I'm going to pause this for a second. You see what happened here is we've switched from 0 at our current level to 1, and our current fall speed went from 1 to 0.9. Okay. So now our piece is falling ever just so slightly faster. Barely noticeable, actually. So that's basically it for you know, making the difficulty a little harder. What we're gonna do next is we're gonna go ahead and add the GUI parts to this to sort of finish it up so that we don't have to keep this debugging this debug log turned on. So yeah, let's I can never stop playing this game. We stop that, and then let's jump into our canvas HUD here and zoom in on that a little bit. All right, so this is our score, and we should probably add a descriptor here, but first let's just duplicate this. I'm gonna do this, all right, and I'm gonna move that down. And then let's see, we've got score level, and we don't need fall speed, but it would be nice to keep track of how many lines we've cleared. Yeah, let's do that. So let's duplicate this one. All right, and then what we'll do is let's duplicate this one again. And let's change a couple of things about it. Let's make it a little smaller. So align it to the left, or to the middle, in the center. Or no, let's just align it right. And we'll do right score. Now we can also make the height a little less. 70, maybe 60. Yeah, that looks good. Alright, so we'll do this. Okay, we'll move these down a little bit. our score. And we'll duplicate this one. We'll call this one level. Duplicate it again. Call this one lines. Okay. So, let's see here. This is score. Call this level text. Let's rename that. And this will be lines text. This will be score text. Descriptor. Level. And lines text. Alright. So now what we need is we need to actually go into our game script. See how we have our HUD score variable here? We need to create a HUD level and a HUD lines. Okay, so let's go back into MonoDevelop and go up here. Where do we have that? HUD score here. So we'll do public text HUD level and public text HUD lines. Okay. Then let's go back in here and we'll make sure that we assign these properly. So we'll just drag them. So level and lines. Okay. Alright, now we just need to make sure that we're updating those. And we'll do that in here in MonoDevelop. And I believe we have an update score method. Yep. So we'll do, we've got an update UI method. Okay, that comes in handy. So we'll just say HUD level.text equals current level, and HUD lines.text equals num lines cleared. Okay. So now we'll have, you know what, let's go in and, oh, those are integers, so we need to actually convert those to strings. So we'll just say toString. Alright. And let's go ahead and remove our debug logs. So right here, and update, and update level, and right here, and update speed. Save that, go back into here. Errors are gone, let's click play. So we got level 0, score 0, line 0, okay. Here. So we're going with our score. Let's see if we can actually clear some lines. Alright, 11 lines and level 1. Shall we play to level 2? No, let's just leave it at this. Alright, so here we are. We've got, what did we do? We optimized some code. We added some difficulty by adding the ability to level up based on the number of lines cleared. You know, the other thing that you could do is as difficulty increases, you can reward the player by offering more points. So like for instance, we have our score values here, right? Score 1 line, 2 line, 3 line, 4 line. What you could do is you could add in score 1 line, all right? So update score, cleared 1 line, score 1 line. Okay, so here we're incrementing the score 1 line. What you could do to add more score is you could add a multiplier, right? So you could do score 1 line times current level, or do we do, well, we'll do plus current level times let's try times current level plus 20, maybe. All right, so if we're at, so let's say we start out with score one line equals 40. All right, so the score equals 40. Where was I? All right, the score equals 40 initially. Okay, so initially, this isn't going to change. Sure it will. Okay, so here's what we need to do. Is we need to do plus current level times 20. So and you can make this any value that you want, all right? So what we're doing here is we're saying 40 plus, and if we're at level 0, then it'll be 0. Score one line, so it's 40 plus 0, so we're still at 40. But once we get to level 1, we're going to do current level times 20, so that's 1 times 20. So we've got 20 plus 40, that'll give us 60 for our next score. And here, if we're at level 2, then we've got plus 40, so we're now getting 80 added to our score every time. And this goes on and on as the levels go up. So for level 3, then we add 60, level 4 is 80, you know, that kind of thing. And you could do the same thing here for 2 lines, okay? And for 2 lines, because you're already getting more points for 2 lines, you could do a higher value here too. So you could do times 25. And then for here, you could do plus current level times 30. And then plus current level times 40, whatever you want to do. So that's another thing that you can add in to make the game more fun. As you move up in levels, you get more points, which makes sense because if you're playing something that's more difficult, you should be rewarded with more points, right? Otherwise, why would you want to even play to that difficulty? Then again, the points really don't mean anything other than, you know, what, bragging rights maybe? Oh, I got the level 9, I got 100,000 points. How many do you have? Maybe something like that, whatever. So, you know, and this is a good way to make the game more fun. So we've got that, we've got the lines cleared, we've got the level. The next video, one of you guys had asked me to add in a slider to select the level. And I think what I'll do the next video is do kind of like a how to set up your menu system and your settings and things like that, because if any of you have ever played Tetris on like the Game Boy, or I think even on the Nintendo it was this way, when you first start the game, it allows you to select which level you want to start from. So in this case, we could actually have a little slider that allows us to slide to from level 0 to level 1. Or sorry, level 0 to level 10. Yeah. Or level 9 in this case, because level 9 should be the last level. Although the games go up to level 20, and that's it's a little different. We would have to do different kinds of calculations to get up that high. This will get you started. If you have any questions, feel free to ask. Always happy to answer and help out any way I can. Alright guys, so that's pretty much it. Stay tuned for the next tutorial, and I will see you guys soon.